Take a look at this setup. This is an industrial drum roaster, a massive piece of mechanical engineering that the specialty coffee industry often uses as a barrier to entry. The prevailing wisdom says that if you want true artisan quality beans, you have to invest upward of $10,000 and operate a full-scale commercial facility. But this is a $20 hot air popcorn popper from a thrift store, and today we're going to use it to achieve the exact same chemical results. The question is whether basic thermal physics will allow a cheap kitchen appliance to replicate the flavor profile of a professional roasting operation. Because at its core, roasting coffee is a heat-driven chemical process. Once you understand the science, you can produce cafe-quality beans at home without a massive budget. Traditional commercial roasters function like a heavy-duty clothes dryer. They apply heat by constantly tumbling the green beans against the hot metal walls of a spinning drum. A popcorn popper takes a different approach. It acts as a miniature fluid bed roaster, forcing a high-velocity stream of intense hot air through the bottom of the chamber. As you can see in this cross-section, those upward air vectors physically lift and suspend the beans in a continuous rotation, keeping them off the heating element. This intense convection creates an incredibly even heat transfer. The beans circulate uniformly in the hot air mass, which helps avoid the scorched spots that can happen in expensive metal drums. Every roast starts with raw material that looks like this. These are dense, green, unroasted coffee seeds, and they contain an internal moisture content of about 10 to 12%. The moment you drop them into the heat stream, the drying stage begins. That intense heat causes the internal water to boil and turn into pressurized steam inside the cellular structure. Over the first few minutes, those dense green seeds transition into a pale yellow, emitting a distinct grassy aroma that smells almost exactly like wet hay. Once the moisture is driven out, the internal temperature rapidly climbs toward the 300-degree Fahrenheit mark. This is the thermal threshold where the real chemistry takes over. Here is the Maillard reaction. Amino acids and reducing sugars violently collide and restructure, generating hundreds of complex flavor compounds. As they form, the bean expands, causing the papery outer skin, the chaff, to flake off and blow out of the chamber. As steam pressure maximizes, the rigid cellular walls literally fracture open. You hear a distinct audible pop, exactly like popping corn. We call this first crack. That sound is a universal physical indicator. Whether you are using $10,000 of steel or cheap plastic, that audible pop proves your raw seed has officially become drinkable coffee. However, air poppers have a potential drawback. They push so much heat that they can fly through this entire chemical process in just 4 to 6 minutes, which often doesn't allow for deep sugar development. To solve this, we use a basic electrical trick. By plugging the popper into a 50-foot heavy-duty extension cord, we alter the energy input. The long cord creates electrical resistance, causing a subtle drop in the voltage reaching the machine. The lower heat output slows the total roast time by a few minutes, giving those sugars more time to caramelize without burning. While a static adjustment, this use of electrical resistance prevents the flash roasting typical of small appliances and allows the home roaster to mimic the slower development cycles of industrial gear. We put this hacked popcorn roast on a cupping table directly next to a batch pulled from a $10,000 commercial drum roaster to taste the results. The commercial batch delivered a very specific profile. The constant contact with hot metal produced a cup with a heavy, syrupy body and a deep, smoky sweetness. But the air popper's profile was different. Because it relies on clean convection heat and roasts rapidly, it preserves the bright, tea-like, and acidic qualities of the coffee. If you love a clean, vibrant pour-over, the thrift store appliance doesn't just compete, it wins. This proves that high price points aren't the only way to achieve premium results. Have you ever tried roasting your own coffee at home, or are you still relying on the cafe down the street? Let us know about your experience in the comments below, and make sure you like and subscribe so you never fall for another coffee gatekeeping myth. Next up, we're looking at why your expensive burr grinder might be producing invisible dust that is secretly ruining your extraction. See you there!